Hello, and welcome to Chapter 13, Quasi-Experiments. Sometimes quasi-experiments is the pronunciation used. Whenever we're doing research studies, sometimes certain issues creep up that can get in the way of us doing it in our ideal experimental approach. Ethical constraints or manipulations that we can't do, or controls. We can't create the situations we want to. And so that can be a problem, or practical problems in terms of creating manipulations or control conditions. And maybe we just can't do random assignment for various reasons. Whenever we have that kind of thing, we can still do empirical research, but we have to do it with a recognition of those constraints and attempt to work around them as best we can while still gathering useful data. These types of studies where you don't have proper manipulation, experimental manipulation, and random assignment, we tend to call quasi or quasi experimental designs. The term means essentially resembling true experiments, but the lack of manipulation and random assignment are elements that you will see in them. There's a couple of different flavors of them that your book focuses upon. Quasi-experimental independent groups design are studies that resemble a true experiment with multiple independent groups. This term is termed more properly a non-equivalent control group design. And the idea behind saying non-equivalent control group is to kind of capture the notion of your control group cannot be judged to be the same as the manipulated group. The two groups are different in some fundamental way. That's why they exist as groups, because you did not do random assignment. You did not have the ability to create those groups in a way that ensures them being equivalent. Though we have some ways of getting at some of that we'll get to later. Of course, we recall that kind of thing is called a selection bias, and that's what we will talk about later. So, to kind of illustrate this using a graphic that we've seen before, when we create a true experiment, we will be randomly assigning people to be in the various conditions of the study. And so whatever kind of unique characteristics they may bring into the study is being randomly distributed into the conditions of the study. And therefore we have some confidence that the two conditions of the study are comprised of people that are more or less similar to each other. However, in the quasi-experiment, we don't have that capability. The persons are being assigned to the study based upon some characteristic that makes them a group, one group versus another. As such, they differ in some known way, and that known way is probably, in fact, what we're taking advantage of for the purposes of our creation of a study. Let me tell you a little bit about a study that is of the non-equivalent control group variety. What this study is about is one that I did many years ago about testosterone changes in basketball fans. You may remember that I've mentioned a study that only had 8 participants, yet still is considered to have enough participants to be a publishable study. This is a published study, along with another study with about 20 odd participants. What we did was we measured testosterone before and after viewing a basketball games and 4 fans supporting each team. In actuality, I approached more than 4 fans. I think it was 6 for one of the teams and 7 or 8 for the other team, but only 4 fans for each team left the second saliva sample that was needed to do this study. So what we were doing is measuring the changes in testosterone from before to after the game. And we were expecting, and indeed saw, that it was higher for fans of the winning team than fans of the losing team. This was a Georgia Tech versus University of Georgia basketball game where I did this study. And I approached the fans and asked them before the game, please provide us with saliva. You can measure testosterone in saliva. And then left them with the materials they need to provide me with a saliva sample after the game. And as it turned out, by the end of the game, we had Georgia Tech fans as winners and University of Georgia fans as losers. And of course, I didn't know who was going to win the game beforehand. It was a pair of closely matched teams. They went into overtime, and the game ended really on a very much a last-second kind of shot. And so it was not a situation where at halftime you kind of knew what the outcome was, or even 5 minutes before the end of the game. Still, we were able to see these kinds of differences, where for the Georgia Tech fans, 3 of the 4 fans had an increase in testosterone, with only 1 having no change. By the way, these are all male fans. We could have measured female fans, but it would have added a lot of variance, because women generally have about a tenth as much testosterone as men do, and it would have required a lot of statistical adjustment. Then the University of Georgia fans, you'll notice that had observed their team lose. 3 of the 4 of them had a drop in testosterone, with 1 having a very small increase. And so when we average the 2 groups, the mean T's change, or our average change in testosterone across the 4 fans in each group, you can see the winners had an increase of about 1.275, and the losers decrease of a little bit shy of 1. Now, this is actually a statistically significant difference. It doesn't look like it's that big a deal, but in actuality, when you don't really know the units of measurement here, but that's about the kind of changes we see happen in a person's testosterone over the course of a day. You wake up in the morning with more testosterone circulating in your body than you have in the evening hours. And in fact, this game was played in the evening, and it's a period of time where declines in testosterone are fairly substantial. And so the University of Georgia fans may indeed be reflecting just normal drops in testosterone, whereas the Georgia Tech fans are showing an increase that is in contrast to what would normally be a decreasing period of time. This study was published in 1998, though the data was collected, if I'm not mistaken, in 1992. Repeated measures varieties of quasi-experimental designs are taking advantage of events that are going to serve as the manipulation. Participants are measured before and after to see if changes in the dependent variable occurs that are attributable to the event. Considered a quasi-experimental because the experimenter doesn't have any actual control over the event's occurrence. They just know it's going to occur, or they expect it to occur. You can even create one of these where you don't know when the event's going to occur, you just know it's going to happen eventually, and so you just keep measuring a group of people or samples of people on an ongoing basis until eventually the event occurs, and you can then continue to measure to see what the effect of it was. You'll see people doing research on disasters that do that kind of thing, where they know they measure all kinds of folks on a regular basis along the Gulf Coast, knowing eventually a hurricane will hit that area, some area or another, and they will then have data that they can use for prior to the hurricane, and then after the hurricane they continue to measure in that area. It sounds kind of macabre, but it is actually done that way. I have a friend who does research in that area. Now, these are considered quasi-experimental, as I said, because you don't have any actual control over the event occurring. And so, and there's a formal name for these as well. These are called interrupted time series designs. These tend to have only one group in them, though you can create them with more than that. Let's imagine that we want to see if the proportion of people who used handheld cell phones changed after the implementation of a new law against their use, as we saw recently happen in Maryland. We know when the date of the new law is going to come into effect. We know that date. And we're going to be observing drivers to see if the proportion of drivers that are using handheld cell phones changes before and after the law. And so suppose we count the number of cars, noting the number of drivers using handheld cell phones for each day of 2 weeks leading up to and after implementation of the law. And therefore, with the 2 weeks before and 2 weeks after, the graph might look like this: the proportion of handheld phone users. And you see I have days of the week running along the x-axis: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, and repeating. And I'm imagining the law comes into effect on a Monday. That's not a guarantee, obviously, but for purposes of this imagined study, there you go. And we have imagined proportions hovering around the upper 20s, 30%-ish before, and then afterwards hovering around 10%. That's what we might see. And we would call this, this would look like evidence in support of the fact that when the law came into effect, it did decrease the overall number of persons using handheld cell phones while they were driving. The details of how we made these observations and all the rest are obviously very important, and that way, if you're fully designing a study, you would come up with a plan for where you're going to do your observations, how you're going to do your observations, to determine if a person has a actual handheld phone up against their face or if they're just scratching an itch when they drove by you. How are you going to know the difference? And operationalizing your measures is obviously very important in all of our studies to get good construct validity. Another design that we can do in a quasi-experimental landscape is a non-equivalent control group interrupted time series design. Wow, this is getting to be a real mouthful. This is essentially the combination of both the non-equivalent control group and the interrupted time series design. Imagine instead of wanting to see if there's a number of people driving, or maybe in addition to that, we're also going to see if there is a change in the quality of driving from before to after the implementation of the law. So we have two groups of people who are going to who we believe will be differently affected by the implementation of the law. Handheld cell phone users who will need to change their behaviors, and non-handheld users who will not have to change their behavior. This method, as I said before, kind of combines the independent groups quasi-experimental method and the time series method. And again, they are non-equivalent groups because we know that they differ on some characteristic. Now, in this version of the study, let's suppose that we're observing people at stop signs and we're counting commonly seen minor driving errors and noting who is on a handheld phone or not. And we're going to be, therefore, able to see this person holding a handheld phone made like one error or three errors or something like that. Errors like, did they come to a stop ahead of the stop sign or not? Did they cross over the line? Did they come to a full stop? Did they use their turn signal? Did they look both ways before they proceeded? Did they have to avoid going into the intersection because of apparent inattention? Did they notice a pedestrian? All kinds of things that relatively minor, unless of course they result in an actual accident. And I'm imagining that we're collecting data in this case on the course of weeks, and there's a reason for that. I want to illustrate a possibility of an outcome. If we look at this, we see that before the law, in the week before the law, or actually the 4 weeks before the law, we are measuring the average number of driving errors per person that we observed, either on a handheld phone or not. And I'm imagining that the handheld phone persons are typically making on an average of 2 errors. That's probably higher. All of this is probably higher than we would actually see. But the non-handheld persons are averaging about 1 error per attempt per time they arrive at the stop sign. And then we have the law get implemented, and there's a closure. The handheld using persons immediately shift in their behavior and begin acting better. They're still out there. They're still handheld phone users, and we would expect that it's a much lower number based upon the ideas in the previously described study. But nevertheless, it's a great closure in the degree of bad behavior, that even if you are still driving with your handheld phone, you probably are greatly aware of there's a reason this law went into effect, and you're going to kind of behave. You're going to have a real awareness of how your behavior might matter, and you're probably going to reduce the amount of bad behaviors you're doing, and really focus on being a good driver even though you're still talking on your phone. But over time, I'm imagining that this drifts and you begin to return to your former baseline. And indeed, we see that often in these kinds of studies where an event occurs and then eventually people do return to their former baseline. And that's what I've illustrated here, that by about, up until about week 13 or 14, there's not much difference between the handheld using persons and the non-handheld using persons. But once you get to about week 14, 15, 16, and that there's a gap that persists from then on, and the handheld using persons are consistently making more errors than the non-handheld users, which are staying pretty much the same as they were before the implementation of the law. And by the time we get to the 22nd week or so, pretty much handheld users look like they're having similar behavior. Now, this is all imagined data. None of this is real data that's been collected. It's a study that I've kind of imagined doing over the years, but, hey, resources and time, it's all about that. Now, there's all kinds of internal validity issues that we want to pay attention to. We want to be able to say that these differences are causal, that the difference in handheld phone use and non-handheld phone use causes people to make more driving errors. We want to be able to say that the law caused people to use their handheld phone less and that their behavior was better for at least some short period of time. We want to be able to say those things. But we know that making causal attributions requires temporal precedence, which we can establish often in these kinds of studies, but also that we know that there's none of these other threats to internal validity, that we know we've got a study that's solid in its internal characteristics. Selection effects, design confounds, maturation, history, all these things that we've talked about before, attrition, testing and instrumentation, observer bias, and so forth. These are all things that could be issues, and these are things that we've talked about in prior chapters. I'm going to touch on a few of these in some detail in the next few minutes. We talk about selection. That's kind of like the big issue, and it's a big issue mainly for independent groups versions of this, either the non-equivalent control group or the non-equivalent control group time series design. And therefore, and in fact, you see the terminology recognizing that selection is an issue by describing them as non-equivalent control groups. But we can reduce these issues, and one of our main tools for doing that is with matched groups. We don't eliminate it completely because actual differences are still obviously there. But if you pre-test people on some relevant variable for your study, you may be able to match them up with people in the two different groups, and therefore manage some of the issues of differences that might be attributable to one group versus the other, and therefore leave it only to the characteristic you're really interested in. It's possible that in a time series study, the confounding factors such as design, maturation, and history can coincide with the event that you're using as the manipulation. For instance, it could very well be unknown to you that there's a crackdown in the traffic and seeking out traffic violations, that the cops go out there and they're looking for people to be behaving badly in an attempt to rein in bad driving. You can have a general, and that would be a design issue where you didn't know that was coinciding with the manipulation, and you're unaware that it could be an alternative explanation for the better behavior. People become aware of it pretty quickly. Could be an aging driving population, that is maturation. It just coincides that a significant shift starts to occur right at the time that you're doing your measurements. There could also be a history event where a notable accident that's attributable to cell phone use occurs and people become aware of it. So all these things, and they look very similar from a data perspective, could be occurring when you do these, and you have to kind of keep your eyes and ears open for the possibility that these things are going on. Attrition is a potential issue where you can lose participants, and then it could make an effect look larger or smaller than if they'd stayed in the study. When you lose a person in the study, it could be because they're exceptionally high performing or exceptionally low performing. They become frustrated or tired or fatigued, and it could matter a lot. And you don't know why someone ceased to be in your study always. Now, in the studies that I use for examples, we really can't suffer from that effect much. Well, actually, in the testosterone and sports fan study, there is an attrition issue potentially, as it turns out that the number of fans that we lost were similar in the two groups. Furthermore, we had their testosterone samples from before the game, and we were able to show that the testosterone levels of the fans that did not continue in the study were not different from the fans who did continue in the study. And so we were able to kind of manage that particular issue. In the other studies I've described, we actually aren't seeing the same people over and over and over again. At least we don't expect them to. It's going to be a different group, and therefore attrition is probably not going to be a good explanation because you're not actually trying to keep people who persist in the study repeatedly. Though people persisting in the study is the classic versions of a quasi-experimental design. Testing and instrumentation can be a significant problem. As in any study, we can have drift in the observer's judgments when you have them making judgments over periods of time, over longer periods of time. Therefore, you want to make sure you do good calibration of your equipment if you're using mechanical or electronic equipment to make observations, or you do retraining and interrelator reliability checks to ensure that you don't have a drift in your observer's judgment. Observer bias, demand characteristics, and placebos are all possibilities. Now, demand characteristics is usually not much of an issue because the experimenter's not doing any manipulating, though it is possible. That is to say that the experimenter, if they have a personal interaction with the persons involved in the study, could ask questions in a manner or style that elicits responses of one type or another based upon the experimenter's awareness of the condition that the person is in. And so it can be very important to have the experimenter either be blind to what's going on or to take great care to have high levels of training and monitoring to ensure that that kind of thing does not happen much. Observer bias, however, is always a big potential issue in any study, particularly where you've got judgments being made about what's going on. Let me give you an example. I did a study a couple of years ago with undergraduate students here at Frostburg State on political yard signs. What I had them do was observe the political yard signs of people before and after Election Day. And our hypothesis was that signs would stay up longer for winning candidates than for losing candidates, and this is based upon the concept of basking in reflected glory. People want to advertise that they're affiliated with successful other things. And we also, I also predicted, or we predicted in our study, that we would see this basking in reflected glory effect more likely in high-profile contests rather than low-profile contests. That is to say, those that are people are generally very aware of the outcome and are interested in the outcome compared to those where people, at least not generally, always there's a few people that are particularly interested, but general awareness of, of the issues and outcome is much lower. The hypothesis was supported. The effect was seen for the U.S. presidential contest. 40% of Obama's signs stayed up, while only 24% of Romney's signs stayed up after the manipulation day of the election outcome. That is, when you know there's been a decision about who won and who lost. None of the other contests, we had U.S. Senate, mayoral races, city commission races, ballot questions on marriage equality, and betting, some kind of gambling initiative was out there. There were persons running for school board and a variety of contests. And there were all these, none of the other ones, Senate, Congress, whatever they were, none of those had showed the basking and reflected glory effect where winner signs stayed up more for losing signs, only in the U.S. presidential contest. Now, you can say obviously the U.S. presidential contest is higher in profile, but you want to actually justify that statement. And we did it based upon looking at Google Trends analysis, where you can look at the number of searches on various search terms, and you can constrain it to periods of time and areas of the world. We were able to constrain it to Maryland, searches originating within Maryland during the weeks leading up to Election Day. If you want to see more about this study, there's a poster in the hallways that you can look at. But there's a little bit of a potential issue that it relates to observer bias. My research assistants could not help but be aware of Obama versus Romney contest, the U.S. president contest, and they were aware of the basic hypothesis of the study about basking in reflected glory, that winner signs should stay up in greater numbers. And so what you've got is persons that the potential for observer bias, and that the most high public profile contest, well, yeah, they're going to tend to know. That's why it's high public profile. They were not aware of the hypothesis, however, about public profile. They didn't know that was part of what we were going to be doing data analysis on. I kept that from them. That was not something they knew about. Still, though, they could have been affected. Let me show you how I described it in the discussion section. One issue with this study that must be addressed is the possibility of experimenter expectancy, another way of saying observer bias. In gathering data, research assistants could not help but be aware that this was a study of the Burge basking in reflected glory effect, even though they were unaware of the hypothesis that relative publicity would be an explored factor. Consistent with the hypothesis, all research assistants knew who won the U.S. presidential contest prior to post-election data collection, but they were not aware of the outcome of the other contest. I asked the research assistants, "Hey, do y'all know who won governor? Do y'all know who won? I know actually governor wasn't being contested. Do y'all know who won Senate? Do y'all know who won Congress, et cetera, et cetera?" And they didn't know. They genuinely didn't, but they knew who won presidency. Continuing the quote. Therefore, it is possible they searched more diligently for Obama signs than Romney signs after the election, possibly seeing more of the remaining Obama signs. To let you know a little bit about the design of the study so you know why that matters, what we did was, before Election Day, we drove through numerous neighborhoods around the state of Maryland and recorded the address and what signs were on display at house after house after house. About 500 houses. A lot of data. And so we've gathered all this data, and then after Election Day, we go back to all these houses. We look for the address, and then we note which signs are still up. And that's the key thing. If you know the hypothesis of the study and you're aware of the outcome of the Obama-Romney presidential campaign, then you want to find those Obama signs because they support the hypothesis, right? And so there's a motivational factor here. You're putting in all this work, hours and hours of effort in training, getting ready, testing, gathering data, and so forth. You don't want to waste that effort. So there's a high motivational factor for people to find Obama signs. But we had another angle to pursue for the main question and to eliminate that issue. We had also looked neighborhood to neighborhood, and we were able to classify some neighborhoods as having high political interest and some having low political interest. That is, in some neighborhoods, there's high general interest and publicity in politics, and in others, low general interest in politics. And we based that on the proportion of total houses in the neighborhood that had signs up at all. Now, the reason this all matters is based upon the reason for us thinking that publicity matters for basking in reflected glory. If basking in reflected glory is a way of me managing my self-esteem by showing that I'm associated with a winner, it only helps my self-esteem if I'm showing I'm associated with a winner that I kind of am aware other people care about. And so I know that everybody's talking about the presidential race. And I kind of know they're not talking much about the Senate race or the Congress race or the mayor's race, etc. And I'm also aware of my neighborhood having a lot of people that are interested in politics compared to other neighborhoods I drive through where there's not that many signs up. I know if my neighborhood cares or not just by seeing, relatively speaking, how many signs there are. These are reasonable assumptions to make about people. And so we would expect, if the purpose is I'm going to advertise where advertising will do me good, either in the contest that I know people are talking about, or in the place I live being a place where people care, then we would expect to see the basking and reflected glory effect only in the neighborhoods that have high interest. And we saw that. The effect for more signs for Obama staying up than Romney was only seen in the neighborhoods with high political interest based on that measure. That is to say, in the neighborhoods that had low political interest, there was not that much difference in the number of signs up for Obama and Romney. It was not a statistically significant difference. But in the neighborhoods where there was a lot of political interest, comparatively, there was a statistically significant difference in the proportion of signs for Obama that stayed up compared to the proportion that stayed up for Romney. Continuing the quote in the discussion section. However, the second test of the hypothesis, the one I was just describing to you, provides a strong argument against that alternative explanation for the findings, that persons are preferentially seeking out Obama signs. The second research assistants were unaware of the hypothesis that neighborhood sign density may be a factor influencing the Burge effect with political yard signs. If experimenter expectancy were operating, the Burge effect should be apparent in the lower sign density neighborhoods, but it was not. Therefore, experimenter expectancy is unlikely alternative explanations for the findings. So, by showing that a situation in the study in which the observer bias was not seen, though it would be expected to be seen, means that it is an unlikely threat to the internal validity of the study. This is a study that was recently published in North American Journal of Psychology. So in summary, about quasi-experimental methods. They are available to examine questions in which cases of ethics, practicality, or other difficulties make true experimentation impossible. By careful design, alternative explanations for causality can be reduced, but we can never fully eliminate them. We just have to make careful, cautious descriptions in our interpretations of our findings. Thank you for your attention, and I'll see you next time.